Alright, just check if my mic is working here. Alright, so here's the problem solved. In anticipation of this problem, we spent the past several days taking photos around campus, all of which were saved on a digital camera as JPEGs on a memory card. Fortunately, we somehow deleted them all. Thankfully, in the computer world, deleted tends not to be deleted. So much is forgotten. Even though the camera insists that the card is not blank, we're pretty sure that's not quite true. Indeed, we're hoping or expecting you're getting ready a program that recovers the photos for us. In a file called recover.c, in a folder called cover, write a program to recover JPEGs from a memory card. Interesting. Interesting. Let me just first duplicate that, and let's go to Visual Studio Code here. Log in. Let's get rid of these. I mean, I could keep them up if it's necessary. No, I don't think they're necessary though. For now. I heard people say that volume could be useful for recover, but no idea. All this updates. Huh. Interesting. Yeah, let's open this. I'm gonna download the distribution code first. Execute this. So, oops. I don't think it's letting me paste right now. It's still loading. It's probably still updating. It's gonna take some time to update. Wow, this is really slow. Really slow. I have no idea if this is because of not. Let me see the speed of my going at right now. Ooh. Let me actually do the speed test here. I have no idea. I feel like it's because of the. Let's do this. Oh my goodness. The Wi-Fi is good. I don't see why it's doing this. My goodness, downloads. Yep, it's fine. I don't know why. 30 frames or less. Let me change the frame rate settings. Stream output. Okay, so I think it worked. Okay, so now let's go set up the terminal again. Where's the terminal reset thing? Imaging reset terminal. Okay, cool. Hello. This is a dollar sign. Okay, with that going on. Okay, so I can just go and create. I'm gonna copy that. Is it here? Volume world plurality. Nope. All right, we have recovered it. Execute this. Now we unzip it, and then okay. Now let's create a folder, I guess, by removing the zip. Yes, and then now just go. I guess we can just do this. Should be there. Okay, and now we can just Okay, cool. And now if we look inside of there, should be two things inside of there. We should card.raw and recover.c. Pop that open. Recover.c is right here. Okay, cool. So we've got the basic stuff done. Okay, some libraries and okay, so we have an argument inside the main function. All right, cool. All right, so background. Even though JPEGs are more complicated than BMPs, JPEGs have signatures, patterns of bytes that can distinguish them from other file formats. Specifically, the first 3 bytes of JPEGs are OXFF, OXD8, and OXFF. Okay, interesting. So the first 3 bytes are this. All right, cool. From the first byte to the third byte, left to right. The fourth byte, meanwhile, is either OXE0, OXE1. Do I see a pattern? OXE1, OXE3, OXE4, OXE. Put another way, the fourth byte's 4 bits are 110. Okay. Odds are, if you find this pattern of 4 bytes on media, known to store photos, they demarcate the start of JPEG. Do fairy byte cards? Is it an exact science? Okay. There's contiguous limit records whereby each photo is stored immediately after the previously taken photo. According to the storage usually demarks the end of another. The FAT file system, or FAT file system, whose block size is 512 bytes. The implication is that these cameras only write to those cards in units of 512B. A photo that's 1 MB thus takes up 104,000. Wait, that's a million. It's a million total. But those is photo. Create just 1 more byte. Wasted space, and it's called slack space. Suspicious data. Cool. So the implication of all these details is that you, the investigator, probably write a program that writes over a copy of my memory card looking for JPEG's signatures. Each time you find a signature, you can open a new file for writing. So basically, you're opening a file every time you find a signature. Okay. Open a new file for writing and start filling that file bytes from my memory card, closing that file only once you encounter another signature. Okay, let's see here. So each time you find a signature, you can open a new file for writing and start filling. If a byte from my memory card, closing that file only once you encounter another signature. But rather than read my memory card's bytes one at a time, you can refire into all of them at a time into a buffer for sure. Yes, it is. You need to only look for those signatures in a block. This is extremely confusing. Extremely confusing. Everything in week 4 has been extremely confusing to me, and I don't know if you have used pointers or not, because that was the main idea. But so far, I haven't used any pointers yet. But if I'm gonna have to use pointers for this, it's gonna be interesting. Okay. Okay, so we've already got the bytes, I guess, in card.raw. Machine code, what the heck? That's just a bunch of machine code. I think so. Hmm. I don't know. I'm just gonna close that for now. It looks a little scary, but yeah. Um. Hmm. 50 JPEGs in there. Hmm. What is a forensic image? I don't know. Oh, it's everything. So it has data, deleted files, unused space. Hmm. Okay. So one command line argument. Yeah. If argc is not equal to 2. Okay, makes sense. That's perfect. That makes perfect sense. This, yeah, that part. This is a pseudocode, except a single line. I'm going to open the memory card, right? While there's still data left to read in the memory card, create JPEGs for the data. So this is basically our kind of thing. So you have to accept a single command line argument, which is okay. Let me just also pop open volume, because I'm pretty sure it's similar to what we did in volume. Yeah. Yeah. This is command line arguments, but this is not equal to 4. But this is a single one, so it's not equal to 2. You can have our own message. Doesn't really matter what our message is. It's just saying, oh, it's a usage instead. Oh, say it's we made a mistake. So return 1 just means, oh, you made a mistake. Or it just means like, oh, it's not return 0, so it means it didn't run properly. You can use any other number. Okay. Hold up. Honestly, I don't like how I do this. I honestly want to like do it like this, whatever they do, like this. You wanna, yeah. Honestly, I was gonna take theirs because it looks nicer. It looks way nicer than mine's. Yeah, there we go. So yeah, just print this on a new line. Yeah, of course. Return 1, beautiful. Okay, so our first part is done, accepting a single one. Now we need to open the memory card. So you use file. What's going on here? Open memory card. So file, pointer to card, you left. Hello, what is going on? Because I know we have a file. Yeah, card.raw. Yeah, okay, that makes sense. We're basically, oh, okay. Okay, so now we need to open the memory card. So we need to access the stuff in there. Let me list out everything because I don't want to be like, oh, I don't know what I'm doing. And then there's also, while there's still data left to read, create JPEGs from data while there's. So potentially this gives us a hint, right? You have to use a while loop, question mark? I don't know. Maybe you have to use a while loop, maybe you don't. No idea. Well, there's still data left to read from the memory card, create JPEGs from data. So while data left to read. I don't know if this is a while loop. Are they using a while loop? Just a quick hint. Yeah, they are. They are. So, open the memory card and while loop through. While they're still have to read from memory, make JPEGs. Okay. So for that, we're gonna make a pointer to, I guess, card. I don't know, file. What does this stand for? What does like file? Is that the name of our thing? We're calling it file. Am I tweaking out? Hold up. Let me ask CS50 duck because that's what we need to do. Where's my friend the CS50 duck? What does this? I'm very dumb. Did I use this? I did. But I didn't write any of this. I just didn't even look at this. Oh my goodness. This is exactly what, so open the file, determine it. You have to use this. File, name of the file, which in this case was input. You have to put whatever file type is, just the name of the file. So in this case, it's going to be file, and the name of the file is going to be, hold up. This is a card, so file, card, and the way they're doing it is, if is, you have F open, we probably have to close it later, but F open, and argv index 1, that makes sense. It should be the same type of idea for this. Yeah. Yeah. And argv index 1 and R. Okay. Oh, probably read. I'm actually so stupid. What does the R stand for? What does the R stand for? Stands for read mode. Yep. I knew it. Read mode. Read. Okay. Yeah. So okay. Does that do this pointer thing correctly? Oh no. Okay, so now we're opening the memory card. Cool, that makes sense. And now we have to use a while loop to actually go through, create a buffer for a block of data. Just like we did. Just like we did here, we made a buffer. Let me just change this to what it should be. You're self-studying C. Studying C. Just seeing if the connection is right. Okay. So here we have a F open argv1 read. Cool. So now we've done that. Now we have to make a buffer. We did make a buffer here as well, I'm pretty sure. Yeah, we did. You can see how we made a buffer, but you know the byte size for a buffer. They kind of tell us that. I want to just completely understand what a buffer is. What is a buffer in this sense? So a buffer is basically a temporary storage area in memory used to hold data while it is being transferred between two places, such as between a file and your program. So it's like a buffer. So, mm, yeah, temperature over the buffer. Yep. Recall it further that card or offer for 12 bytes. Mm-hmm. Yeah. So then we want to probably use it. Wait. Yeah, use this type. Okay. Uh, yeah. I forgot. They forgot to include one file here, my friend. They forgot to include hashtag include. There's some other types that they did not include here. You have to include my friend. What's it called? This one over here. This type is necessary for us here. So it's going to be int 8. What's it called? Int 8 underscore t. Yep. And it's going to be calling. I'm going to call it buffer. And it's going to be how big? It said 512, right? 512 bytes. This should be how we make the buffer, I'm pretty sure. Yeah. Create buffer, temporary storage. Make buffer for temporary storage. Okay, so we've done that. We've opened the card. We've created buffer for temporary storage. We've opened the file, quote unquote file. Then create a buffer for temporary storage. Okay, cool. And we've done that part. So how do we make sure that, okay, it's probably not the best idea though to use fire until it's a magic number here. Odds are you could improve this design further. Now consider how to read data from memory card. True, if there's somehow goes beyond this, we're going to be accessing some weird memory for, I don't know, for something. Or it's going to be weird. The thing's going to be really weird. I don't know. Magic numbers. So we don't want to use magic and be like, oh, where did you get the 512? Remember, Dave, like Milan talking about how you should just pull these numbers out of nowhere. Just pulled 512 out of the air. But yeah, I guess that's fine. I guess because they're basically saying do it. Per now consider how to read it. Per its manual page, fread returns the number of bytes that it has read, in which case it should either return 512 or 0. Given that card raw contains some number of 512 byte blocks in order to read every block from card raw, it should suffice to use a loop like this. So while fread buffer. That makes sense. Yep. Okay, so here we're gonna use a while loop. Yeah, bro, C actually is tough. C is pretty tough. C is pretty interesting. Alright, so now I've done that. Now what we need to do is start our while loop, I guess. So while there's still data left to read from memory card. Okay. Okay. Claim buffer. It's the array of byte 1 to 512. 512. Okay. Making sure. Okay, that makes sense. I don't know if I'm doing this correct. I don't even know like the proper format for this. Buffer is the array 1 12. This is equal. Sure, like that. So that's what I think is the right format. I don't know if that's the right format. Yeah, we'll have to see. Okay, there we go. Oh, okay. Hey, whoever's there. Okay, so here we've got our while loop kind of set up here. Now that was, I guess, the difficult part is to create the JPEGs from the data. I have no idea how to create JPEGs. Well, that's why I'm going to be watching this video. Okay. Okay. That makes sense. We see something. So your first 3 bytes. So your first thing you have to do, your first 3 bytes are going to be, sorry, wrong one, OXFF, OXD8, so OXFF, OXFF, OXD8, XD8, and then OXFF again. And then these are the first 3 bytes, so I know this is going to be the starting of a JPEG. So the adjustment extent. Okay. So keep looking for JPEG headers. That's a clue here. Keep looking for JPEG header. JPEG headers. Okay. Yeah, we got that. We did this part. That's good. Wait, have we done this? Read files. No. Yeah, this is difficult. This is a pretty difficult thing to do. Okay. Okay, this is gonna be a pretty interesting step. So I guess you could have a counter for every single thing you could have. Okay, so I guess header. Huh. Okay. A little confused. A little confused. A little confused on that. Huh. Okay. So while f read buffer 1 512 is equal to 512, while loop through maliciously, we're going to make JPEGs. From here, we assessed. Talks about those conditions. I'm 99% sure he talks about those conditions. count this integer is equal to 0. So if buffer is buffer index 0 is equal to let's say, what is it, ox, I think we have to might turn this, I don't know, ff, and then I don't know if I can do and I don't know, buffer index 1 is equal to ox d, this is probably a way to do this, ox d8 and what was my and buffer 2 is equal to So how will we do this? Huh. So if we have okay, so instead of using fopen, we're use sprintf. And in there we're gonna have our file name and then I guess 0%03i.jpg. Okay. Okay, so this is going to be the changing value dependent on my header counter. So depending on this right here, or header value, we're going to be changing our sprintf. That's pretty chill. I think I can do it. So file name, and then this is where I need help. This thing. I don't even know what this is. Percentage. So string percentage 0.3 is 0.3i percentage 0.3i and .jpg. Yep. Is it JPEG? No, it's just JPG. And then we're gonna have our number, which is gonna be headers. I think that's how you do it. This could work. This could not work. So I don't know. We are keeping track of headers. It starts at 0 though. It starts at 0, and every time this thing iterates, oh, it's going to be 1, and then it iterates again. It's gonna be 2, and then we're gonna write. Let me see how well this is gonna be. Let's see if this is. Make sure to declare initialize file name. Huh. Open new file using fopen. Oh, you think we do have to use fopen? Yeah, before we write, we have to fopen. File name. File name. How do we initialize file name? It's gonna be like, oh, show me some code. Show me it was a okay, never mind. It knows. It can actually help me here. Okay. So char file name, you can initialize them as a character array, for example. Char file name 8. Up, I guess we'll initialize it here. And boom. You can just character array. 1, 2, 3, 4, 5. Yeah, I get what they need. 8. Interesting. Okay. fopen, fwrite. Okay, fopen. So open the file using. Open the new file using. So I need to. Initialize file name. So open file name. I don't even know if it's called file name. Okay, and then fwrite. I need to write into the file, basically. What do I write into it? What? Wait. Where do I write the buffer into the file? So, how do I use fwrite? I'm pretty sure we use fwrite here. Okay, so we have, oh, see? We basically have to, I guess, get the address of the buffer, and then this thing, the size of, okay, and then whatever output file is going to be called. Ampersand buffer. Ampersand. Where's the ampersand? Ampersand buffer. And then we're going to get, ampersand buffer. F open file name ampersand buffer. Maybe we do. Is there any special things for it? Huh. Because do we have anything in here that's hashtag stdio hashtag already include of everything, but I don't know why it's not highlighting up here when I'm doing it. I don't know. So ampersand buffer, and then what else do we have here? Size of and CT. Huh. I don't know how to finish this. I don't know if I want to use size of. We'll see. What should be my next step? Let's see here. So you're almost right there. Everything's complete. Move declaration of int header 0 outside the while loop. Okay. Oh, that's true. I don't want that to be declared outside. True. Add a semicolon. Okay. Declaration out here. And then add a semicolon after char file name 8. So correct this printf by closing the string and adding closing parentheses. So correct printf by closing the string and adding closing parentheses. What? Closing string? What do you mean closing string? I don't understand as printf. I don't understand. I'm actually goofing out right now. Missing closing. Oh wait, what? It's the closing string. Oh yeah, closing string. Oh, I'm an idiot. Headers. Okay. Should look okay. Cool. And then correct the printf and closing, and then use fopen to open the file for. Is there a problem? Problem with my. Okay, you should maybe use fopen. Is this the file name? I highly doubt it, because you're not opening. Should use fopen, but you need to specify the mode for open file. For example, file. Why is it a pointer to what? File. Image is a pointer to a file object. I guess we could use image because it is an image, but I haven't even declared anything about images, even nothing before it. Yeah. We always have to say file before we use fwrite or fread. We potentially do have to use or card. Huh? No. Let me specify the mode for image. Image is mg is a pointer to a file object. Is a pointer to file object that we will use to write to the file. I wouldn't write to the ampersand. I don't even know why. Wait. So this wouldn't work. I'm almost out of the duck, so it's not good. Stream out is good. It's okay. Good. Okay. We should be how you would split that right. Brother. Okay. File ampersand. I'm gonna do exactly what they said and see what happens. I'm just curious. I have no idea how to use fopen. My file IO skills are very terrible. What is W? Okay, no. This is not it. File name. Fopen file name, yes, and then we want to add what? I mean, W, oh, read, oh, right, okay. I have to say what I have to do with it. I'm gonna write to it. I'm actually losing my mind. Okay, there we go. We've done that. So we're opening file name, and we're diving into it. So fwrite ampersand buffer. See if it works now. I mean, what is it gonna say now? Is it not inside of the loop? It's not even inside the loop. This is actually stupid. I completely forget that the loop starts inside the brackets. Correct the fopen statement. Okay. Correct the fopen statement. Okay. Fopen. Maybe it's because I put looks like it's multiplication where it's literally a pointer. We don't look at the address of buffer. We don't care about the address of buffer. Although we don't want the address of buffer. We just want buffer. And it's going to be 5, 12, 1, and I want to ask what this, okay. 12, 1. I need to clarify some stuff. As I hate just copying and pasting the code and not actually understanding what's going on. So 5, 12, and 1. Image. How you would implement these corrections. Okay. What? What is wrong with my fopen statement? Oh my goodness. This is stupid. Yep. Restoring stamina. Wait. Yeah, it's kind of unfortunate. How long is this gonna take? I need to make a program to see how long CS50 duck takes to restore stamina. It's quite a bit tragic, actually. Okay, just finished it. I feel this should be 99% better now. Small syntax error, and then I see, oh, it should work, right? It looks like you have a small typo. The correct file should be file, not. Oh my goodness. Okay. Okay, I see. Oh, an idiot. It's just like the top one, man. Oh my goodness. This is not even like. See, it sounds highlighted up in red now. Honestly, I could use the CS50 duck here. Duck debugger. Debugger, let's see it. I swear, it's another one here. Feed duck. It is an AI, so I mean. Decision. This was CS50. Deep learning. While we wait, why don't we just look at deep learning and stuff? Different using neural networks where problems and solutions are explored. For example, deep learning may attempt to predict whether blue or red dot appear somewhere in the graph, considering a following image. So something up. Okay. Damn, this duck is taking forever to start it. Come on, where is it? Where are you? It's not even here. It's like the duck got cooked or something. CS50X duck. Come on. I think it's right here. If I copy this, it should get it. There we go. Okay, there it is. Okay. Anything wrong with this? This looks pretty perfectly on camera. I feel like what you should be encountering. Do you see any faults? Do you think any problems here? Any problems here that you see? Okay. So, see if you should think of calls for the opening memory card files incorrect. It should be open. Wait, what's wrong? Wait. Oh my goodness, that's actually true. The way I'm using F open right now is absolutely terrible. Where is it? Where is it? Yeah, what in the world? Okay, it's a simple issue. It can be fixed. Okay, you should check if the file is open. You should close it. Let me try. Should I close the file after? Do you think I should close the file? I mean, it's not open. Yes, you should close the file if you're going to use the folder. After I open it, of course. So if I'm F opening it, then you should close it after you're done. I feel like the end of your program. Right? End of the program, you should use it. Should I F close? Should I F close? F close at the end. Yes, you should have close to closing files off of this memory card. This includes both the memory card file and any JPEG files you create, written, and resources are freed. That's important. That's important. We have limited RAM. So okay, so let's F close. I guess just like how we opened it, we have to close it. So we're going to here at the main F close, and what is it? It's called card. So I guess we have to use file, like the same type of logic. File. I don't know if this is right. This oh, it's because of command line thing. I don't know. That doesn't seem right at all. Doesn't even seem close to right. F close. This is all I need. F close. Close card. Yeah, that makes sense. Why am I even? Oh my goodness. Okay. And then you should also. Okay, so be closing it. This is wrong. We should do file. This file out as a file operation. Okay, we close it, and also for the JPEG files, we're going to. So I guess we have to F close. Oh, since we're opening it, we have to close it after we write to it. Makes perfect sense. F close, and it's going to be file name. Boom. Now I want to see how well this is. Oh my goodness. So I don't think we need the file at the very end. It should just be F close IMG, F close. Close card. and F close. That's how it should be. So it should be F close card and F close ing. Because this is because they're, oh my goodness, we're writing it. You can clearly see like the pattern here, clearly. So this should be card and this should be image. There's an issue there, issue here, now here. See now what you got, what you got. Ah, is that in the dang while loop? Ooh, card. As a while loop and adding a check for card. What do you mean check for card? Is this inside the while loop right now? There's no way this is inside the while loop right now. Ah, it is inside the while loop. Well, that is inside the while loop. This is some stupid stuff, and my function's probably not even closed. I thought that was me because I'm a stupid guy. What am I doing? What am I doing? Let's just F close card. Let's close the card there. And what else did they tell me to do? They said, can you F placement F close card? Okay. It should be outside the while loop. Yep. And also make sure the file is successfully opened. Can you try moving F close card outside the while loop and adding a check for card? Okay. Also make sure to check if the file is successfully open. Can you try moving F close? Check. What do you mean check for card? Let me ask this one here. How can I add a check for card? Upload or you a statement right after attempting to open a file. Do we need it though? Is it really gonna be necessary? I remember doing this for C++ class. I was making a check to make sure your file is actually open or not. I don't know, like where do you think you should place this check and what should be the condition? And what should the condition be? Where do you think you should place this check? And what should the condition be? Where do you think you should place this check? What should the condition be? Okay, I don't have to place it right after you open it. So if the file is open, if oh yeah, there we go. If card is equal to null. That's basically it. I have no idea what does if something is equal to null. Here's public something equal to null. 2 windows can valid memory address. Okay. If card is equal to null, then you want to printf print out the file. Okay, you can do anything here. I don't think they care, but it's like could not open file. Then you want to put this on a new line. Cool. Also return 1 because it's an error. I don't know why I'm indenting it like this. What is wrong with me? Okay, there we go. So yeah, we got that. Oh my days, let's put close in here. Okay. Okay, so we basically have a check for it. Cool. So now what do we do? What are we gonna do now? We can check, but no idea how to do it. Okay, we see what it has to say about this now. This has to be good, right? Oh my god, it's a keyword. It's not null, but it should be null. So if we have a keyword, hold up, where is it? It's a keyword, so you have to make sure it's null. And there's a problem. My printf as well. I know it for a fact. There we go. This is perfect to me in my heart. A couple of things you can try the JPEG file you're writing to and close before you opening a new one. You should ensure that you're writing to the current file in a new JPEG header. Okay, so you should keep track of the current JPEG file you're writing to and close it before opening a new one. Okay. I am keeping track of the, because you're increasing headers plus plus, right? Every time, okay, there we go, headers plus plus, and then aren't I not keeping track with headers? Is it not with headers that you want me to keep a track? Headers have a name of file will. You can also give a return file. You should use a current JPEG file before opening. Wait, you should close the current. Headers can help you name the files, but you also need to keep track of the file pointer for the current JPEG file. You should close the current JPEG file for opening. I don't know how to. How do we? You should close the current JPEG file before opening a new. Okay. Am I not doing that? Am I not closing the current JPEG file? Am I not opening the current JPEG file? Okay. So in this case, file name, the correct JPEG file. How do we do that? Okay, F close card. Okay, I am closing it, right? Am I not closing it here? Close the previous file before opening a new one. Close the previous file before opening a new one. Okay. Close the previous file before opening a new one. No, but basically, how do we close it though? But I'm basically closing it here, man. Do I start with F close first? I have no idea. I'm actually stuck. Okay. How do we? What do I close even before? Okay. I don't know how to. To be completely honest with you, I don't know how to. I don't even know how to do that. You're saying you can use a file current image variable to keep track of current file before opening a new file. Check if current image is not null and close it. Okay, so you can use the idea that file image variable to keep track of the current file. Okay. What is it? Okay, what is he going to take in from? I'm going to use the current file before opening a new file. Image is not null and close it. Oh, okay, so we're checking if it's not null. Okay, current image and file name and we have to the current file. Okay, and then before opening a new file, check if current image is not null. So again, just like we did before, we're checking if card is not null. Again, we're gonna do if current square image is null, images. What? Okay, whatever I say. Cannot open file. Yeah, you're not even not open file. New line. Cannot open file. New line. Let me just return 1. Okay. And there's some bad placement there. I mean, do we still have to keep track of it? Then I have to have a counter. I mean. Oh my goodness. Okay, so we already need to declare file. Current image outside the loop, initialize it to null. Is not null and close it. Oh, damn, bruv, damn. There's so much to do. Okay. So first we initialize it to null. So I guess before I even do this, because you can keep that there, but we're gonna just do this. So we could do it right here. File current image is equal to null. Then we can potentially say, okay, if current image is not equal to null. Sorry, why am I doing a Boolean operation? What is wrong with me? Is equal to null, and if current image is not equal to null, then you want to close the file. So we use f close current image. F close current image. Just like what are we there? img, and we're gonna be looking inside of current image. And I'm using f close just to do that. That's all I have to do. This looks pretty good to me. I just don't know what it is wrong. What? Okay. This should be chilling right now. Come on. Oh yeah. You should declare it. Yeah, without the file name parameter. Okay, what am I doing? Well, it didn't know what file name is. What am I doing? File name parameter is equal to null. Okay, what the hell? Redeclaring it. File name W. Let me see this part. I'm just gonna give it this chunk. This isn't much for UCS50. Yeah, you should be able to handle this, my friend. Very close to issues that you're using cooling for really after writing to, so you should queue it on the next JPEG header. Okay, try to remove the f close current image line inside the if block and move outside the loop. You're very close. The main issue is that you're closing current image immediately after writing to it. Oh yeah, okay. If block. What the hell? So you're gonna move this thing right out of it. So you don't even want an if block. What is this, the point of this then? Should be the right image. So, try moving the curve goes outside the if statement that checks for the JPEG header. So out of the while loop probably is this. Oh my god, I'm such an idiot. Hold up. Take this out. Take that out. Take this out, the while loop. Maybe, okay, maybe you want it outside the if. After, oh, okay, that's okay, that makes so much more sense. Yep. That makes so much more sense. Yep. Appreciate it, F4IZA. Okay. I moved the closing out of the if. So every time it's gonna only close after it finds the next header. Okay, after it's done with this header, and then it's gonna close. After it's done with the header, and then it's gonna close. Let's go to the next one. Yeah, I get it. Okay, that makes sense. Okay, I don't think there's any more issues with this code. I mean, honestly, I'm not. Come on now, come on. Ooh, okay, it looks like you're closing current image inside the loop, which will close the file after every block read. I forgot to remove this. Oh my goodness gracious. Hold on. Looks like you're closing current. Looks like you're closing current image inside the loop. Only when you find a new JPEG header or at the end of the loop. Can you try moving F close current image inside the if statement that checks for the JPEG header, but only for writing the buffer to the file? It's right here. This way you close the file only when you start a new JPEG or at the end of the loop. This way you close the file only when you start a new JPEG or at the end of the loop. Okay, so it's saying to move my F close after writing the buffer to the file. So, wait. Yeah, we are writing the buffer to the file. I'm just kind of cooked. Outside loop. Outside the while loop? Sure. I'm gonna put it outside the while loop. I don't know. We'll see that now. Why would you only close it create only when you find a new JPEG header? That makes sense. What am I? Oh my goodness! Only if it's not even a. What is wrong with me? If I'm increasing header even if it's null, that's gonna give me some weird file names. So only after that. There we go. There we go. let's try this. This is probably pretty good. Oh, too much for you to handle. Okay, brother. Okay, brother. Alright, let's go here. Okay, now work. You gotta work now. You gotta work. You gotta work. Gonna try. Or you should also write to current image when you don't find a new JPEG header. They try adding the fwrite statement outside the if block that checks for a JPEG header. Outside the, okay, so you want me to change? You try adding the fwrite statement outside the if block that checks for the JPEG header. So you want to add it outside of it as well. So you want me to add an fwrite as well. Same type of thing. This just seems so dang off, man. This just seems off. Very off. Okay, can you move the further call inside the if block? The if block and keep them outside the block. Right now, when you're okay, okay, but it kind of makes sense. I'm a little confused on that as well. So you don't want this one, but you want the one outside the if block. We're writing either way though. That makes sense. Okay. Okay. Let's grab that. See now. I mean, if I can take that, but now it should be pretty close. I mean, I don't see any problems. This is a minor problem. And if there was bigger problems, it would tell me if there was a bigger problem. Make sure to check grammar yourself for call. Okay. Image is null for calling fwrite to avoid. Alright, check current image before the fwrite call. So you want me to do a check for current image before fwrite. Okay. So before I do this, where is it? So before I do this, you want to see if it's null. So if current image. Same thing. But inside this thing. Like this. I don't even know if this is what I want. I don't even know if this is right, bro. This is very weird. I don't know. It's really speechless right now. The AI is speechless. So am I. Oh boy, it looks like you're. Oh, can you try moving the close current image? Can you try moving the close current image inside the if current? I don't even know what's going on at this point, bro. This is actually cooked. Very, very cooked. I'm not gonna ask that guy anymore. I want to see what's going on wrong first, and he's gonna give me a good explanation from this one. Check whether current image is null before calling fwrite. So just make sure it's just in the stress of current image is not null. It's not null. Then just do that. Okay, I think that's good now. I think that looks pretty good. Oh my goodness, I think this should work. It says almost there. Oh my goodness. That makes sense, so you don't want it to be null before you write something. Oh, and there's a problem here. I already see it. Oh my goodness, yo. Null should be capped like that. Null should definitely be capped. think there's any problems anymore at this point. I think this is chill. But if there could be other problems, it's insane. Because I've just been fixing these problems forever. Here, how else would you find new JPEG header? Oh my goodness, what did I do wrong? Headers only when you find. I am. Wait, what is going on then? Hold up. Okay. And only when you find a new JPEG file. Okay, make sure to increment headers only when you find a new JPEG header. And you should keep writing to the current file to find the next header. Am I not doing this right? Only when you find a new JPEG header. Yes, because we're basically finding a new JPEG header, right? Because if otherwise it's closed already. Because that doesn't make any sense if it's after that. What is going on then? What's the point? Yeah, it's just me getting mad over here. No, you being grouping headers. You should start headers from 0 and turn value of f up and share that. What? Wait, after. But it's gonna be at 0. Oh, because we're starting at 0, 0, 0. I'm an idiot because it's gonna become. Oh, okay, that's true. Yeah, at this point, I'm just gonna run this. /recover and command line argument. What? No such file directory. What? /recover card dot already no such file recovery. What the heck? Does check 50 is gonna work? Is this gonna work too, or is this gonna give me this error? It's definitely give me some errors, man. People like red, and errors. It doesn't even compile. I didn't even make recover. There we go. There's our problem. I'm an idiot. Okay, so okay, where's that at? So line 34. Yep. What the heck? I swear they told me to do this too. What is the while f read? F read. What's wrong here? Clearly buffer is defined. Clearly. Okay, so it's just this. Is this a bracket issue? It's not a bracket issue because it's 1, 2. Do we need another bracket? Is that what you want every sir? There's no need. It's so excessive for a bracket, man. Let me just grab this f read here. I don't see a single difference between these two. I don't see it. If this now we have this error now in line 39. So it's telling me that there's something wrong with this. Please put these around this expression sounds this morning. The issue with this is over that the bitwise operation share the correct order of operations. Bitwise, yeah, it's not bitwise operation. So we wanna put parentheses around that part, that and that and that. So around this, like that, and also this part needs to have parentheses. I'm pretty sure something like that. And this part is a special parentheses? No. Okay, no, it's just the regular closing braces here. And you just have to have these like that. Now let's run it. Okay, it runs down. Perfect. It works. Now we just have to check if it worked out. Please. Please. Okay, let's go back. Explorer. Yeah, and it recovered it. That's cool. It recovered all the pictures. Look at all these cool pictures. It's from Harvard. The duck. Look at that. Oh my goodness gracious. This was a pretty challenging problem. Honestly, it wasn't as hard as substitution, which took almost 7 hours or something like that, but this was rough. Indeed, very difficult. Very, very, like, you know, tough. It's very tough. Yeah, I'm gonna actually check 50. Just sure it works. I mean, there's a total of, in this case, 49. Maybe that's an issue. Maybe it's supposed to be 50 images. Wait. Did they say? Oh no, hold up. How many did they say here? No. Okay, they don't say exactly how many, so it's fine. But we're gonna see though. If this is gonna give me a problem, then I know there should be more images. Check 50. Yep. Okay. That's cool. So now I'm gonna do style 50 to make sure everything's. There's gonna be so many issues with my style. There'll be like 150 issues with my style. Look at that. What did I say? Some I'm just gonna skip because I'm just too lazy to fix, but easy ones I'm gonna just quickly go through it. Okay, what's wrong? Oh, it's way too long. I'm not breaking this up, good sir. I'm not breaking this up. Okay. Missing a parenthesis. Also indentation is very off for this one. Okay. Indentation was off. What? Okay. Space. Boom. Boom. This one, boom. Indent. Space. Do that. Boom. Now I've got this problem, which they want me to make it like this. So they want me to split it here and bring the other part down here, like so. Okay, there we go. So what I need to do is I need to make sure check 50 works again, make sure it works, make sure I didn't destroy anything. And yeah, that should be it. That should be it. Almost. Oh, it looks pretty good. Looks at 49. See, this last one was recovered. And yeah, the last one was recovered. Honestly, oh, it covers middle images correctly. Who knows what middle images they're talking about here? But yeah, I mean, looks pretty good to me. We can submit it. Pretty proud about this. Didn't take too long, but it did take long. It was a pretty inherently, and the duck helped me so much on this. Yeah, this. Yep. Yeah. I clearly did not do anything bad. I clearly used CS50i, and we're clearly chilling. Okay, chill. 7 out of 7 and 1. That's good. We're basically finished recover. great. Yeah, and so that's all gonna be for the stream. Hope everything was chill. Have a great day.